Hello class! Today we are starting a new unit, and the first lesson in this unit is all about angle pairs. And so our notes today are going to go over a lot of different vocabulary words, so hang tight and make sure that you can clearly differentiate between each different type of angle. So the first thing that's really important to know is the definition of what parallel lines are. Parallel lines are two lines on the same plane that do not intersect. That means that they never cross. So in this picture below, we have two parallel lines right here, line M and line N. Sometimes to show that these lines are parallel, there will be little arrows pointing in the same direction. So parallel lines never touch. You could say that they don't really like each other very much, so they're always going to be an equal distance apart from each other. But a transversal line is any line that intersects two lines. So in this case, it would be line K. So line K crosses two lines, M and N, and we call this a transversal. Now, one really important property that you need to know is that the angles of a line add up to 180 degrees. That is why when you have a straight line, it can also be called a straight angle. And the measurement of this angle is 180 degrees. This will become really useful in the future when you are calculating what a certain angle is given the measurement of another angle. So a couple of more definitions. Alternate angles are on opposite sides of the transversal. So where's the transversal? We said that it was line K. To be on opposite sides means that they wouldn't be on the same side of this line. So 1 and 4 would be alternate angles because 1 is on the left side of this transversal and 4 is on the right side. Or 5 and 6 are alternate angles because 5 is on the left side of the transversal and 6 is on the right side of the transversal. Next one is interior angles, and if you know the word interior, like interior design, interior means the inside. So interior angles are on the inside of parallel lines. So first, it's helpful to identify where your parallel lines are. We have M and N, and so everything on the inside of these two lines. Imagine that these are the borders, and you want to see everything that's inside these two lines. So 3, 4, 5, and 6 would be interior angles. They're on the inside of the two parallel lines. So an exterior means outside of parallel lines. So not between these two parallel lines, anything on the outside. So 1, 2, and 7, and 8 are all exterior angles. So if two angles are supplementary, that means they add up to 180 degrees. If they're complementary, that means they add up to 90 degrees. And if they're congruent, that means their angle measures are identical. Or in other words, they're exactly the same. So when you have two parallel lines that are intersected by a transversal, you have many different angle properties. So let's look at a few of them. For each of these, we're going to look at what the definition of the pair is, the relationship between the angle measures, and then examples. So for alternate exterior, if you remember, we said alternate means on opposite sides of the transversal, and exterior means outside of the parallel lines. So that's it for the description. Opposite sides of transversal. And then outside of the parallel lines. So, for example, 1 and 8 would be alternate exterior angles because they are on the opposite sides and they are outside of the parallel lines. So, what do you notice about angle 1 and angle 8? Their angle measures are actually congruent. So whatever angle 1 is, angle 8 is also. Alternate interior angles, remember alternate means opposite sides of the transversal again. And they're on the inside of the parallel lines. So again, now we're looking on the inside. So opposite sides on the inside, for example, angles 3 and angle 6 would be alternate interior angles. And they are also congruent. If you look at angle 3 and at angle 6, if you rotated this around, you would see that it's exactly the same thing. So now we have same side exterior. So same side seems pretty self-explanatory. It's on the same side of the transversal. And then exterior, you know, means outside of the parallel lines. So, if we're looking to the left side of line K, left side because it has to be on the same side of the transversal, but outside of the parallel lines, we could see angle 1 and angle 7. Now these two angles do not look exactly the same. Angle 7 looks much bigger. So these two are actually supplementary when it comes to their measures. That means when you add up the measure of angle 1 and you add up the measure of angle 7, you'll get 180 degrees. Same side interior, remember same side means same side of the transversal. And interior means inside of parallel lines. So if we're looking on the inside, same side, for example, angle 3 and angle 5. And these are also supplementary. Alright, moving on. If you have corresponding angles, this means that they have the same position, but at different intersections. So remember, an intersection is where two lines cross. So our two different intersections would be right here and right here, where K and M cross and where K and N cross. And so if they had the same position, you notice that 1, 2, and 3, and 4 look very similar, actually exactly the same as 5, 6, 7, 8. So the same positions, for example, would be 2 and 6. They're both at the upper right-hand corner of each intersection. So these two angles are congruent. Adjacent angles mean that they are right next to each other. In other words, they're neighbors. So if we're looking at angle 1, an adjacent angle could be angle 2, or it could be angle 3. So we know that adjacent angles are supplementary because they always form a straight line. 1 and 2 form a straight line right here, and 1 and 3 form a straight line right here. So they are supplementary. One, angle 3. Now, finally, vertical angles are angles that are opposite at the same interaction. finally, vertical angles are angles that are opposite at the same intersection. So let's say we're looking at the intersection of M and K. Let's say we're looking at 1 again. What is opposite of 1? It's not adjacent, it's not right next to, it's opposite. So 1 and 4 would be vertical angles. Now notice that this angle here and this angle here are mirror images of each other. They're exactly the same. So we have congruent angle measures. Great. So this is a lot of memorization of definitions, but remember, each word tells you something about the angle in relation to either the transversal or to the parallel lines. So once you start looking at examples of these, if you will memorize these definitions and the angle measure relationships, it should become quite easy to remember. One cool thing that I want you to write down on your contract is that if you have one angle measure, you can find all angle measures. For example, let's just say that angle 1 is 60 degrees. Okay, so we know that a straight line has to equal 180 degrees, right? So what must angle 2 be? What plus 60 equals 180? That would be 120 degrees. Then we know that angle 1 and angle 4 are vertical angles, so they're congruent. So that means angle 4 is also 60 degrees. And angle 2 and angle 3 are also vertical angles, so angle 3 is also 120 degrees. Now we know that corresponding angles, which means same position at different intersections, so 2 and 6 have the same angle measurement. So 6 would also be 120 degrees. And then 6 and 8 form a straight line, so 8 must be 60 degrees because 120 plus 60 is 180. And then 7 is a vertical angle with 6, this is also 120. 5 and 8 are also vertical angles. So just by knowing one angle measure, you were able to quickly find 8 different angle measures with small calculations, easy calculations. So now before you begin on your independent practice, I want you to find at least one more example of each of these using the diagram. There's at least 2 examples for every single one of them. We only covered one, so I want you to find your own examples.